Welcome to Module 6, Developing REST APIs. We'll begin with Section 1, Introduction. At the end of this module, you should be able to recognize APIs, describe Amazon API Gateway, indicate the steps for developing REST APIs with API Gateway, and use API Gateway to create, publish, maintain, monitor, and secure APIs. In this module, you'll learn about APIs and API Gateway, creating a REST API, and integrating with API Gateway. You'll also learn about deploying an API, controlling access to a REST API, monitoring a REST API, and optimizing API Gateway. Product information for the cafe is now being stored in a database, and Sophia wants to use an API to integrate it with the website. She wants to test the front end and get approval from Frank and Martha before completing the full integration. To use an API to access the data in the Amazon DynamoDB table, Sophia needs to modify the website to use an API Gateway endpoint. Before she implements the production integration to DynamoDB, Sophia plans to show Nikhil how to test updates, and she wants to get approval from the owners. She can use a mock endpoint in API Gateway to quickly create and test the API and demonstrate it for the owners. After she tests and gets approval, she can update the backend integration to connect to the DynamoDB table. This diagram gives an overview of the application you will build through the labs in this course. The highlighted portions are relevant to this module. As highlighted in the diagram, you will use API Gateway endpoints to enable the website to request and retrieve data through an API. You will use mock endpoints to test the front-end integration rather than integrating with the database. Thanks for watching. We'll see you in the next video. Section 2, Introducing APIs. An application programming interface, or API, simplifies programming by abstracting the underlying implementation and only exposing objects or actions the developer needs. It is an interface or method that establishes how two pieces of software can communicate. As use of the cloud has dramatically increased, a lot of vendors are integrating with the APIs of cloud providers that host the solution. It's important that these solutions have their own APIs so you can continue to automate the resources that the underlying cloud provider offers, but also programmatically get at the data from the solution itself. In a typical web application, clients send requests and get responses from an API that resides on a web server. The API provides the interface to application resources such as databases. Web services offer APIs for developers to use. For example, social networks like Facebook or Twitter and payment processing services like Amazon Pay and PayPal provide APIs for developers. APIs provide a way for developers to write code that works with those applications, but that is also controlled and safe for the program. Code can then be entered that sends requests to the receiving software, and data can be returned. API requests use a standard protocol like SOAP, WebSockets, or HTTP. A request from a device reaches the server, and then the server responds with a status code and potentially some data. Whether a client application runs as a website or a native application, it usually gives some dynamic data back to the client application. This process is usually carried out through an HTTP application protocol that humans can read and is commonplace across the internet. Thus, developing for heterogeneous systems is relatively easy. Even in cases where a client application is using SOAP, it still usually transmits requests by using HTTP. WebSockets and server-side, event-driven applications are becoming more popular with the advent of real-time applications, and WebSockets use a different bidirectional protocol. This bidirectional behavior allows for richer types of client-service interactions because services can push data to clients without a client needing to make an explicit request. WebSocket APIs are often used in real-time applications, such as chat applications, multiplayer games, and financial trading platforms. Response status codes fall into a few main categories. The first category is successful response status codes. These are in the 200 range, such as 200 and 201. Status codes in the 400 range, such as 403 or 412, tell the requesting client that they must do something differently. For example, they passed an incorrect password or did not pass the information that the server needed to fulfill the request. Finally, status codes in the 500 range, such as 500 or 501, indicate that something went wrong, but the problem was not on the client side. An example is when a server encounters a programming error or resource failure during request handling. APIs are often categorized as either RESTful APIs or WebSocket APIs, but this wording is an oversimplification. Representational State Transfer, or REST, is purely an architectural style or pattern for creating web services and structuring requests from a client to a server. APIs that you build that adhere to REST principles are called RESTful APIs. When a RESTful API is called, the server transfers to the client a representation of the state of the requested resource. Non-RESTful APIs that use HTTP are valid and quite common. Here are the key takeaways for this section of the module. APIs simplify development by abstracting implementation details and providing a shared definition of how to communicate with an application. Clients send requests to an API and get a response back. And finally, REST is a standard way to structure API requests. Thanks for watching. We'll see you in the next video. Section 3, Part 1, Introducing API Gateway. An API gateway acts as a proxy between your client and server or servers behind a load balancer. An API gateway accepts all API calls, aggregates the various services required to fulfill them, and returns the appropriate result. The gateway handles most of the common problems that developers encounter when managing dynamic server-driven applications. Without an API gateway or proxy between the client and the server, you would need to programmatically handle everything at the server. This would not be a good use of the server's processing capabilities. It's better to abstract some core common functionality out of the server and position it as a standalone proxy. For example, you could have the proxy rate limit the application so that the server is not overwhelmed. Here, the proxy is similar to a doorman in a nightclub. The gateway could also ensure that requests contain the required developer keys. Perhaps you have an API that is designed for various developers or sites to consume. Examples are Twitter or Google Maps, where you get an API key. The proxy can validate requests and drop invalid requests before they even get to your server. You could also use a gateway to limit access based on language headers or geographical regions. In some cases, it might reroute to the correct server for that locale. So, what is Amazon API Gateway? It is a fully managed serverless service that developers can use to easily create, publish, maintain, monitor, secure, and operate APIs at any scale. API Gateway acts as the front door for applications to access data, business logic, or functionality from your backend services. Amazon API Gateway can easily be linked to other AWS services. For example, you might not want to maintain a server. You might choose to go serverless. API Gateway can intercept requests from clients and adjust the data if needed before forwarding information to AWS Lambda, for example. Then, while returning data, API Gateway can potentially adjust the data from Lambda before sending it back to the client. Not all HTTP requests that a client application generates are classified as RESTful. However, for simplicity, the term RESTful is used in this module to distinguish between WebSockets and HTTP. Amazon API Gateway offers two options to create RESTful APIs, meaning HTTP APIs and REST APIs, as well as an option to create WebSocket APIs. Thanks for watching. We'll see you in the next video. Section 3, Part 2, Introducing API Gateway. We'll first look at using RESTful APIs in Amazon API Gateway. When you create a REST API in API Gateway, you enter Advanced mode. You can manipulate the requests that come in and go out, have fine-grained control over highly customized authentication options, and can set up mock endpoints. You might find that you don't need all of those features. For example, you might only need a proxy in front of a Lambda function. You can't directly access Lambda from client applications by using a standard HTTP request because Lambda endpoints are not publicly accessible URIs. You must use either an AWS SDK for that purpose or put something in front of the function to take the request and transform it into a Lambda payload. You also need something to transform the response from Lambda on its way back to the client. If you need API Gateway only for this purpose, use the API Gateway HTTP API type. HTTP APIs are optimized to build APIs that proxy to Lambda functions or HTTP backends, making them ideal for serverless workloads. They do not currently offer API management functionality. As HTTP APIs mature, features currently available only with REST APIs will be added. Unless you need advanced features or need to monetize your API, choose the HTTP type for your APIs in API Gateway. Next, we'll discuss using WebSocket APIs in Amazon API Gateway. WebSocket-based APIs are bidirectional in nature. This means that a client can send messages to a service, and services can independently send messages to its clients. This bidirectional behavior allows for richer types of client-service interactions because services can push data to clients without a client needing to make an explicit request. Without more detail, this image looks like standard HTTP requests going back and forth between clients. But with a closer look at the requests, you find the benefit of WebSockets for this type of communication. A typical HTTP request requires much ancillary information to function. It contains headers and other bits of information, such as connection bearer tokens for authentication. The actual data, for example, "Hi there," is small compared to the extraneous data that goes back and forth for every HTTP interaction. If an application needs to send and receive a large volume of messages, it's better to set up a two-way pipe between client and server. After the initial setup, both sides can send small, efficient messages back and forth freely. It is unnecessary and costly to send header information for every interaction. WebSockets is a standard for setting up this two-way pipe, and it handles issues such as retries and broken connections. You can also set your WebSockets routing to indicate which backend services should be invoked based on characteristics such as message content. Examples of such services include Lambda, Amazon Kinesis, or an HTTP endpoint. For a secure encrypted version of WebSockets, or WS, use Secure WebSockets, or WSS. You can create and work with API Gateway APIs by using the AWS Management Console, the AWS Command Line Interface called the AWS CLI, Swagger, and OpenAPI to document and share your API definitions. AWS provides several deployment frameworks that can be used to write infrastructure as code and deploy your APIs in the cloud. The AWS Serverless Application Model, known as AWS SAM, and the AWS SAM CLI are particularly useful for locally testing and deploying APIs as part of a serverless application. AWS SAM is a superset of AWS CloudFormation, but provides a simplified syntax for common serverless components. You can use CloudFormation to write infrastructure as code that uses a common language. It supports YAML and JSON templates. CloudFormation automates the provisioning and ongoing updates of resources. The AWS Cloud Development Kit, or AWS CDK, uses the familiarity and expressive power of programming languages to model your applications. It provides a library of constructs that covers many AWS services and features. The AWS CDK provisions resources with CloudFormation. Here are the key takeaways from this section of the module. Amazon API Gateway is a fully managed service that provides API proxy and simplifies API development. API Gateway supports RESTful and WebSocket APIs. API Gateway integration with AWS services frees developers from writing integration code. Thanks for watching. We'll see you in the next video. Section 4, creating a REST API. When you create and deploy a REST API, or the versatile and cost-efficient HTTP API, API Gateway generates a URI. This URI has the components that are illustrated in this slide. An API stage is a logical reference to a lifecycle state of your API. For example, dev, prod, beta, or version 2. You'll learn more about the stages later in this module. You can create and invoke your APIs with the API Gateway console or the AWS CLI. This slide shows examples of creating an HTTP API in API Gateway. With either of the examples on the slide, the result is an HTTP API that is integrated with a Lambda function by using a default catch-all route. It also results in a default stage that is configured to automatically deploy changes. The steps for creating a basic REST API are similar, but some more work is necessary to configure the API. For example, you must create at least one stage and deploy your API to it. You will likely have an API that does more than one task. Therefore, a default endpoint won't give you everything that you need. For example, suppose that you are using API Gateway for a dynamic website. Static content, such as index.html, CSS, or JavaScript, might be hosted on an Amazon Simple Storage Service or Amazon S3 bucket and use specific paths to reach specific API methods to do specific things. In this example, the default endpoint, /products, which gets all products and the get method for a specific product, 34, both route to the readFN function. The put method routes to the updateFN function. For the get example, readFN is written so that it can handle receiving all of the products. For instance, if a variable of product ID is passed to the Lambda function, then it responds with a query instead of a scan. This slide illustrates an example of the code you might use to create the get routes. In the first example, you get a specific product. In the second example, you get all products. This slide illustrates an example of how you could create the put route to update a specific product. Note that the product is identified by the product ID with the updateFN function. Another alternative is to use the greedy path variable proxy plus to capture all path values after the proxy indicator. With proxy plus, you can set up a single Lambda integration that absorbs any nested paths that are included on the API call. With this approach, you let the Lambda function, or other server-based code, react to changes in any of the API resources under the default endpoint. In this example, it is /products. For example, a request like get /products /34 /stuff /more /even more /stuff would be passed to the readFN to be parsed and responded to with that function's logic. This catch-all approach is a simpler API to build, but in general, it is a better practice to use more specific paths. The command to create a WebSocket API is similar to the commands for REST APIs and HTTP APIs. The route select expression is required for WebSockets. It provides information that your server application will need. For example, suppose that you want your API's behavior to be based on the action property of the JSON message you're sending. You include the .action JSON path expression in the route selection expression. The action value in this example would evaluate to the word join, and your server code knows which method to use. Many developers use OpenAPI to create API definitions and publish. You can go to the OpenAPI URL and view the API definitions, and even make the API calls to the endpoints. OpenAPI is a declarative definition file that defines how your API works. When you create APIs, you might want to provide documentation about how to use your API, especially if you're working with third-party developers. You can also use an OpenAPI or Swagger file to build an API from an imported definition. Here are the key takeaways for this section of the module. You can create APIs by using the AWS CLI, using the API Gateway console, or importing an OpenAPI definition. As a best practice, use different paths to perform different actions and connect to different back-end integrations. Thanks for watching. We'll see you in the next video. Section 5, Part 1, Integrating with API Gateway. This slide shows an architecture that is similar to one described earlier in this module. We'll take a closer look to learn a little bit about the API endpoint. An API endpoint type refers to the host name of the API. The endpoint type determines how the API's endpoints, the front end, are deployed and how clients access them. The API endpoint type can be edge optimized, regional, or private, depending where the majority of your API traffic originates. With REST APIs, you have the option of an edge optimized endpoint. With this type, API Gateway uses its own Amazon CloudFront distribution to reduce the round-trip time for your requests and responses. This endpoint type is designed for globally distributed clients. It gives you built-in distributed denial of service, or DDoS protection, through its CloudFront distribution without your needing to set up a separate CloudFront distribution. This option is not available for HTTP or WebSocket APIs. All of the API types, which include REST, HTTP, and WebSocket, support regional endpoints. Regional endpoints are recommended for general use cases and are designed for building APIs for clients in the same AWS region. Note that a best practice is to set up a CloudFront distribution in front of regional endpoints. Websites and other externally focused services will access these endpoints. CloudFront helps to protect against DDoS attacks and to reduce the round-trip time for requests and responses. REST APIs also provide the option of private endpoints, which are accessible from only within Amazon Virtual Private Cloud, known as Amazon VPC. This endpoint type is designed for building APIs that are used internally or by private microservices. In general, you can write your API calls by using HTTPS requests to an API Gateway endpoint. Alternatively, you can use the API Gateway option to export an SDK for your defined API. Then, you can use that SDK with your client-side code to make calls to the API. To call your API programmatically, you must generate a platform or language-specific SDK for it. API Gateway generates custom SDKs for mobile app development with Android and iOS, and for web app development with JavaScript. API Gateway also supports generating SDKs for Ruby and Java. After an API and its models are defined in API Gateway, you can use the console to generate and download a client SDK. Alternatively, use the API Gateway APIs to do so. Client SDKs are generated only for REST APIs in API Gateway. For example, suppose that you're using AJAX calls on your dynamic website. You could generate the JavaScript SDK for your API and use the generated SDK to write calls to the API. When you write your own integration this way, you must have the client send a securely signed payload to your AWS account. In this example, the client is a website that uses JavaScript. Using the generated SDK, you send the securely signed payload to the AWS service endpoint for API Gateway. AWS can unpack that payload and deliver it to API Gateway what it needs to respond to the call. AWS awaits a response, packages it, and sends a secure payload back to the SDK. The SDK converts that message into a response that the JavaScript can work with. Although the generated SDK for the API simplifies coding this integration, the code to build the request payload from the client-side SDK is non-trivial. Additionally, it forces you to work with the API credentials on the client side, which is a bad practice from a security standpoint. For these reasons, the recommended approach is to use HTTPS requests to your API gateway endpoint. This approach is simpler to code and more secure. As a developer, be aware of this option with use cases where it makes sense to connect to the AWS service directly with the SDK. Note that every time you update an API, you must redeploy it and regenerate the SDK to include the updates. Thanks for watching. We'll see you in the next video. Section 5, Part 2, Integrating with API Gateway. Regardless of the endpoint type you choose for your API, you can integrate the API with Lambda and other AWS services. Lambda and many other AWS services are not directly accessible by using HTTP URIs, so you cannot write standard HTTP calls to reach them directly. Instead, use API Gateway to proxy requests to AWS services on the backend. API Gateway can run Lambda functions in your account, connect to DynamoDB or Amazon S3, and start AWS step function state machines. API Gateway can also call HTTP endpoints that are hosted on AWS Elastic Beanstalk or Amazon Elastic Compute Cloud, known as Amazon EC2. In addition, API Gateway can call HTTP-based operations that are not AWS hosted but are accessible from the public internet. You can also integrate API Gateway with other AWS services directly. For example, you could expose an API method in API Gateway that sends data directly to Kinesis. With REST APIs, you have the option of a mock endpoint. Mock endpoints can be used to abstract options, but they're also useful for prototyping front-end applications. Your front-end can call a reliable endpoint to ensure that all infrastructure is in place, and the mock endpoint can return default data. Then, the mock endpoint can be swapped out with a real backend when you're ready to integrate it. A mock endpoint is also useful for delivering secure index.html pages. You'll learn more about mock endpoints when we discuss cross-origin resource sharing, or CORS. In the diagram, notice that you can connect to a VPC link that allows access to resources in a VPC through a load balancer. You can do this for both REST and HTTP APIs. Now we'll take a look at an example of the API integration flow. In API Gateway, an API method embodies a method request and a method response. You set up an API method to define what a client should or must do to submit a request to access the service at the back end, and to define the responses that the client receives in return. An API integration has an integration request and an integration response. An integration request encapsulates an HTTP request that the backend receives. It might or might not differ from the method request that the client submits. An integration response is an HTTP response that encapsulates the output that is returned from the backend. A client uses the API to access a backend feature through the method request. If necessary, API Gateway translates the client request. It translates the request into the form that is acceptable to the backend in the integration request before forwarding the incoming request to the backend. The transformed request is known as the integration request. Similarly, the backend returns the response to API Gateway in the integration response. API Gateway then routes the integration response to the method response before it sends the response to the client. Again, if necessary, API Gateway can map the backend response data to a form that the client expects. Thanks for watching. We'll see you in the next video.